Okay, guys. First of all, I want to apologize that my face isn't coming up. I don't know what's going on with my laptop right now. It just it refuses to allow me to show my face on here for this particular one. I'm not sure why, but I'll figure it out for the next ones. Don't worry. You guys have not seen the last of my face. So anyway, now we're going to get into lesson 2.2. This is going to be all about different types of graphs, okay? All right, so you guys are probably wondering why it's not completely exactly like either book. It's sort of a mixture. I feel like this way sort of makes sense, and we're simplifying everything as much as possible so that it will, we're going to gradually build on it, the whole thing, but so far I just feel like this is a better way to sort of break things down. So I hope it works for you guys too. Anyway, so in this lesson, what we're going to do is we're just going to look at graphs. We are going to look at a time series graph, then we're going to look at a bar graph, and then we're going to look at a pie chart. Okay, and we're going to look at the different graphs, and we're going to figure out exactly when it's a good time to use each of these different types of graphs. Okay? Okay, so the first graph that we're going to look at is the time series graph. So a time series graph is a line graph of repeated measurements taken over regular time intervals. Time is always going to be shown on the x-axis or the horizontal axis, so this one right here, right? And then the intervals or the variables that you are looking at, usually it's going to be in like a percentage or usually like a percentage or maybe a decimal or something, because you're usually look at rates, okay? And that is always going to be on the y-axis, okay? Because those are what we're making measurements of. So anyways, typically on these different graphs, what happens is you will be taking measurements at like regular and time intervals, right? So they're going to be consistent time intervals that you should be taking, and the points are always going to be joined. Okay, so when do we use a time series graph? Okay, you're going to be using time series graphs when you need to measure rates of change. Okay, so a rate of change, and you're not always going to see it in a public health stats book using this term, but rate of change is generally the idea there. You're measuring the rate of change over time. And this type of a graph is really great to use in almost any industry, any discipline. Okay, it's not just going to be in health. Of course, in health, we're going to measure things like cases of influenza or cases of COVID, okay, over time. So it could be how many different cases that show up with COVID over time, maybe in on a weekly basis, or it could be deaths over time. Okay, but you can also use this in other disciplines as well, like I said. So this is the same kind of graph that you use like if you were stock trading and whatnot. So if you're looking at stocks, you're going out to buy your stocks, right? You would be measuring the rate of change in the prices of the stock over time. Okay, so any situation where you need to measure a rate of change, okay, over time, that is when you want to use a time series graph. So when you want to look at those type of of a change. Okay. Okay. So now let's look at how to actually create a time series graph. Okay, so pretend like we are trying to do a study where we can find out how many, how many cases of influenza are happening every year, for example. Okay, so the first step in even creating a time series graph is to go ahead and create your little table here. All right. So you need to get your raw data. Right here, these are your, this is your rate, okay? And then here is your year, because your year, the time, that's gonna be your constant, all right? And you're trying to check, how many, what's the rate of influenza cases per year. So this is gonna be the rate, or this is the variable that you're trying to measure, okay? The variable that you're trying to measure. God, I write terribly. I'm sorry. Anyway, so let's say you already did the math, you figured out the rate per year. Cool. Now the next step in this whole process is for you to draw a horizontal line for the x-axis. Let me go ahead and erase my mess. Erase. Okay, so now you're on this part where you're gonna go ahead and draw a line for the x-axis. Sorry, my lines are really sloppy. And then your x-axis, or your horizontal axis, is going to be where you put what? The time, or the year in this case, because that's the unit of time that we're looking at. So you're going to put time on the x-axis, okay? Time in years. Okay. And then after that, what you're going to do is draw your vertical line. And then go ahead and label this side your percentage rate, or however you're however you're going to graph or measure your data. So it could be just that rate that we had there. You could convert them into percentages, however you want to do this. Percentages are actually really easy and very common to do. But anyway, so you're going to put that on your vertical axis, all right? And then of course you want to make sure that like your highest percentage or your highest measurement or reading is going to fit into the graph, all right? And of course you don't want to make your vertical line axis like way higher than or way larger than your highest either, okay? So this is our highest point. We want to make sure that it's going to fit into the graph, but we don't want the graph to be like this big and, having the highest point down here. So it's going to look like there's nothing up in this space. And that is actually going to create the illusion that's going to make this area or your actual readings kind of scale down. So they might not actually look accurate if you're just looking at it without reading it or, figuring this out. You might actually think that they're smaller values than they actually are. Okay, it's going to trick the mind. Anyway, let me go ahead and erase this. Okay, so the next couple steps in how to draw a time series graph. All right, so the next thing that we have to do, because remember we had in the last one, we created our X and Y axis. We labeled them. We figured out what our, largest point was going to be on the Y axis. So we made sure we set up a graph so that it's going to fit our data in that perfectly, right? That's where we are now. So next, what you're going to start doing is you're going to start plotting the points, all right? So you figure out what time interval you're in, and then you go ahead and plot the point for that, plot the data point for that one, right? And then you figure out the next one, and then you plot the point. You figure out the next one, you plot that point. The next one, you go ahead and plot that point. Okay, because you're doing this against the percentages. And then what you're going to do after that is just go ahead and, connect the dots, and you'll see your graph come out. Okay. Okay, hold on. Let me go ahead and erase this bad boy. And, okay. Ooh. Okay, so one other thing that I wanted to point out here with this graph is that you can actually have more than one, data set going on the same graph, and that's totally okay. Like maybe you're looking at the influenza rates in the United States, and then you also want to compare them to Canada's. So you have data for both, and you could plot them both on the exact same graph, like they did here, and all you have to make sure of when you do this is that you have a legend, okay? So the legend will tell you like which data is what. All right, so just to summarize, time series graphs. So I hope you guys kind of got the idea is that the whole reason why we want to do time series graphs is so that we can kind of understand what trends are happening, over time. Okay, so we can, see what the data is doing or what is actually happening with that population over time or whatever we're studying. So if we were looking at going back to like, influenza, okay, if we were looking at the trend of influenza over, on an annual basis in San Bernardino, if we pretend we're public health workers, okay? And if we saw that over time, actually that would be bad. So if we saw that maybe over time, every year influenza started to do this in San Bernardino, then we would go, oh, okay, great, we're doing something, right. We probably, we should keep up whatever kind of interventions we have going on for the public. Maybe it's, if we're giving out free flu shots, I guess free flu shots is working and we should continue to do that. But what if we saw a trend going and the trend of influenza in San Bernardino was like this? You know what I mean? So, or if we just saw it continuously, like just kind of go up, then we would go, hey, oh my gosh, it looks like we can't get rid of the flu. People are suffering, we're doing something wrong. We need to figure out some sort of public intervention that we can do, that we can put out there, that we can implement with the public to try to bring that number down. Okay, so that's kind of why we do time series graphs. It's just so that we can study these trends, and then if we need to in health, we can look at those trends and we can go, okay, so it looks like in this area we definitely need to, work on that. Maybe we need to add in some sort of intervention. Maybe we need to have some sort of program where we're giving everyone immunizations. We need to do something, okay? So that will tell us if we need to take action. Okay, I think you guys got it. Okay, so in the next few slides, we're going to go over what a bar graph is and what the features are of a bar graph. So first of all, I just want to let you guys know that bar graphs can be used for qualitative data and quantitative data. So the time series graphs, I forgot to mention that those are specifically used for quantitative data. You can't use them for qualitative. But bar graphs, really good for both types of data. Also, we're going to go over how to make a bar graph, and then I'm going to show you what happens when you change the scale of the graph. Because sometimes, like if you were to make the, let's say the vertical or the horizontal axis greater or smaller, and it'll kind of show you how you can change the interpretation of the data and how it'll different, So you kind of have to be mindful sometimes about the scale of how you're making your charts. And then we'll look at what Pareto charts are, and pretty much they're the same thing. Spoiler alert. But anyways, I still want to give a shout out to Pareto charts real quick before we move on to the next type of graph. All right, so some cool features about bar graphs. First of all, bar graphs, they can be horizontal or vertical, or I mean the bar portion. So these ones are vertical, all right, but you know, they could also be plotted like this, like where they're like that, you know, and sorry, I'm trying to make sure you guys get a decent idea about it. And then if that were the case, then the measurements would be down here. Okay. They would be labeled down here on this axis, same thing, how they're labeled right here, sorry. The measurements are on this side. All right, pretend I wrote measurements perfectly. Okay, so bar graphs and histograms. I mean, we just looked at what bar graphs are, and you're probably thinking, what the heck? Isn't this a histogram? But the thing is that it's not. They're very, very similar, and they look pretty much exactly alike, but there are some differences. So let's go over a couple of those differences. All right. So the frequency histogram and the relative frequency histogram are more special cases of bar graphs. Like they're a special kind of a bar graph. I guess if you want to think about it, bar graphs are more like the generic version, and histograms are a little bit more specific. Okay. But they use pretty much the same general structure because they both have like the bars and all that. So anyway, let's look at some of the differences so you can go ahead and distinguish between the two, because you may have some problems that make you distinguish between the two. Okay. The two main differences that you should be aware of are the fact that histograms, okay, are, you know, bar graphs that have their quantitative variable on the x-axis, okay? So it has to be a quantitative variable. What is a quantitative variable? Remember, the quantitative variable, that's quantitative. It is like a measurement, or it's like a steady, it's usually like a constant. Okay, you gotta have like some sort of constant thing going on your x-axis in this area, all right? You gotta have some sort of constant. Whereas if you look at this bar graph, we don't actually have a constant going on in this. These are just categories. Okay, so you can use bar graphs really well with qualitative studies. Okay, so your qualitative studies are pretty good with bar graphs, quantitative of course as well, but the histograms work really well with your quantitative studies and the quantitative stuff that you're doing, because they specifically need you to have like some measured constant on the x-axis. Okay, so you gotta have a quantitative variable, like it could be time, you know, or something like that. And the next difference that you guys need to be aware of is that the y-axis is always going to be a axis. I'm sorry, I write so badly. That's not even a word. Badly. So anyway. Where was I? Relative frequency or frequency? Yes, okay. Yes, because the x-axis, the y-axis where you're going to put your frequencies, those are frequencies, right? It's like how many times, you know, we get this reading over time or something, you know? So we have frequencies going up here in a histogram. But as you can see in this bar graph, we're not doing frequencies, we're doing percentages, or we could be doing something else. It's not necessarily frequencies. So the specific things that make a histogram is when you have a constant going on the x-axis, like temperature or time or something like that, and then you have on the y-axis your frequencies, your frequency or your relative frequency. If it's just a generic bar graph, you don't have to have all those. So it doesn't have to be as specific if it's just a regular bar graph. Just want to point that out. Okay, so guys, remember a while back I told you that I was going to show you what it looks like when you change the scale on these bar graphs that you're doing, and then I'll show you how it kind of changes the perception, or how a lot of people may interpret the graph. Okay, even though it's the same data, but the way you display the information on your graph can really change how people interpret it, or how people just perceive the information on your graph. Okay, so for example, look at this one on the right. This is a graph that is showing the percentage of people who are not covered by health insurance in groups of, ethnic groups. Okay, so right away I want to point out that, look over here at the y-axis. The highest value that they put over here, and these are percents, by the way, is 35%. They put that as their highest value. That's what they chose to put right there. That's the scale that they chose to draw their graph on. Now, look at the highest value that they actually have in their section. Okay, it's a 29.1 for this group. Okay, it's a 29.1%. Now, I mean, this graph is okay, but I feel like it was completely unnecessary to draw the scale up here that huge. It's not necessary. There's a lot of space not covered. So it almost looks like this is the highest value is not as, high as it actually is in a way. It's not too bad here in this graph, but let's pretend for a second, okay, that what if we decided to redraw this graph and we were going to draw it at 30 instead of 35. So pretend that, let me just, I don't know, make it look like I'm blacking out this whole section. Ooh, okay, I have an idea. I'm gonna do it like this. Okay, pretend that the graph was like this, was drawn like this. There is no 35 up here. It's just on a scale of 30%. Does that look a little bit different to you? Okay, it kind of does, right? It's a little bit different. It actually, I think when you look at this graph, you would immediately interpret it as oh no, this group right here, really, that's a terrible situation. This is, we have to do something about this. Almost no one has, a lot of people don't have insurance. This is really bad, and it would probably make you want to take action, okay? Or it would get people rattled up, all right? That's what this type of a graph would do, because given that you're doing it on a 30% scale and your highest value is 29.1, and your highest value is almost touching the, the end of this graph, that, I feel like that would strike some emotions in people, and people interpret this as an emergency. We need to do something about this group. They don't have insurance. Okay, now let me show you what's going to happen if we decided to do the opposite. What if we, instead of scale, what if we went the opposite way and we scaled way, way up? Given how the beginning of this, when we first looked at this graph, it was at a 35%. What if we decided to just double it? What if we went 70% but with the same exact data? Let me show you what that looks like real quick. Okay, so look at this. This is the difference. It's the exact same data. Okay, same. I mean, here's your percentage on the y-axis. So we got our percentages. You know what? I'm just gonna make symbols now. I write terrible. I'm sorry. So it's exactly the same data. Look, 29.1% here, 29.1% here. Okay. The only difference is this is on a huge scale. So we showed 70% as, you know, the highest up here, whereas over here it was 35 originally. Now, what are your thoughts? Just take a second and stare at this graph. Like if someone showed you this one over here, the 70% one, and then they said that this is the percentage of people who are not covered by insurance, you know, grouped by their ethnic group. Would you go, oh my God, that's a big deal. This is a real problem, especially for the Hispanic group. Oh my God, we have to do something. Or would you go, ah, it doesn't look that bad. All right, we're doing okay. Go America. Like, this is the difference. This is how, you know, interpretations of data, we can skew people's perceptions just by, like, you know, scaling it differently. Okay, and this is actually, I mean, this kind of thing is what like politicians will do and things like that, right? Where they try to like skew your perception. They want to alter the data a little bit or just present it in a way that makes you, that gets a reaction out of you. So if you were a politician who was like all about healthcare coverage and everything like that, you would probably be showing the public a graph of, you know, that looked more like this. That was very down to scale, because this graph right here actually makes it look like it's an emergency, right? It makes it look like, okay, we definitely have to do something for this group because they're not insured. Whereas the group on the left, okay, this one makes it seem like it's not a big deal, okay? So, and I mean, even if you went, you could go all the way to 100% up here, and this would look even smaller. So it looked like it's not even that much of a big deal at all. We don't need to do any work there. Okay, so that's the difference. I mean, you know, when you're presenting data. So something to keep in mind. All right, let's move. Okay, so now let's look a little bit more into changing the scale as well as this other type of graph. Well, this is a clustered graph. It basically means more than one bar is graphed for each category, or basically when you have multiple different data sets for certain categories. Pretty much when it gets complicated, this is when you're going to be doing a cluster graph. So like over here, we have multiple different data sets for, you know, the different categories, female, male, both sexes, and the different data sets correspond to the different ethnic groups that they were doing the study with, right? So, you know, if you're doing a study like this, and so you're looking at maybe different ethnic groups or, you know, anything like that, and then you're comparing different categories, you always have to make a legend. You definitely have to make a legend. So this is very well labeled and organized. This is a great graph as an example, but don't ever forget to make a legend. That's like key to doing one of these graphs. Okay, so anyway. Another thing I want to show you about changing the scale a little bit, far from what we looked at in the last slide, but this is another thing that you can do. Okay, so if we look at this graph, this is life expectancy at birth, okay? And then, you know, of course, by different ethnic groups. And then the different categories they had were female, male, and then both sexes. Well, life expectancy at birth, that's gonna, I mean, these bars would have been really, really long, right? Because if you look at the values that they're given, these are really large values because it's age, it's life expectancy, right? So 70s, 80s. It would be a really, really long bar if we didn't go ahead and cut it a little bit short. Okay, so this dash mark right here that there, or hash mark, whatever that is, so that actually means that they cut out maybe like 50 years on this scale. So they changed the scale a little bit. They like chalked out about 50 years, probably because they know that all of these are going to be the exact same thing, okay? So it's okay to cut out around 50 years. You could cut out 25, whatever you need to do to sort of shorten the scale a little bit. But if you're going to do it to one category, you have to be able to do it to all of the categories. So they shorten the scale for all of the categories here so that they can start at pretty much 50, and then they can, you know, make their constant intervals, you know, for the rest of the graph, the data that they have. Okay, so like I said, if you can also do this, but you have to make sure you're shortening them for all of the categories in your chart. Okay. All right, let's move on. All right, so remember I told you guys that I was going to talk about, or just give a quick shout out to Pareto charts. So here we go, quick shout out. We got Pareto charts on the track. JK, okay. All right, anyway. So what this is it's another bar chart. Big whoop, right? Well, this is pretty much a bar chart that likes to focus on problems, okay? It's the kind of thing that focuses on problems or events that happen, and then the problems associated with that event. So in this example, we are going to look at the event that we're looking at is cause of engineering overheating, and then the different, what they have in the categories down here are like the different problems that happen with, or the different, you know, reasons why it overheats, okay? And then over here on your y-axis, okay, this is the x-axis, sorry, let me write that here just so you guys know that that's what that is. All right, so the y-axis is where we put the frequency of each one of these different like events happening, okay, or each one of these different little problems happening. So when your engine overheats, this is telling us that 31 times, you know, in this situation, in this overheating engine situation, it was because of the damaged radiator core, okay? And 20 times it was because of faulty fans, and 8 times it was because of faulty thermostat, and so on and so forth. And so what this does is it likes to list the different problems and the frequency of how many times those problems happen. And what it does is it puts them all in order from like big to small. Okay, so you can see like the order of, you know, how big of a problem it is to how small of a problem something is. Okay. These type of charts do not really happen very often in healthcare. And the reason why you don't really see them, or at least why I believe that we're not seeing them in healthcare very much, is because right away, like when you look at these, it's like you have so many questions, okay? Because let's say, what if we were, I don't know, what if like the problem that we were looking at was like number of, I don't know, just problems in like a healthcare, like an assisted living center, okay, with like older adults, okay, and like one of the problems here would be like maybe this problem would be falls, and this problem could be like influenza or something, you know, and so we could be looking at this and going, oh wow, 31 falls at that assisted living facility, and then we might think, how big of a deal is this really? I mean, is like over the course of an entire year? Is it an entire decade? How many people are even, you know, at this assisted living facility? Do you have like, you know, is it huge? Is it like a 50-bed assisted living facility, or is it like a really small one? Is there like maybe 6 people there? You know, because if there's obviously less people, then 31 falls is super significant and there are problems there. But if it's like, you know, 30 people at the assisted living facility, and this is over a scale of like, you know, a month, or not even a month, like if this were like 6 months or a year or something like that, this would not be a problem. Okay, so in healthcare, I think that we need more details. Okay, we need to know exactly what are we looking at there, and if we use Pareto charts for a lot of healthcare issues, there would just be way too many questions, you know? So, all right, so quick summary of what we did with our bar graph section of this lesson. Okay, so you know, bar graphs must be made following just a few rules. Remember that there are going to be differences between bar graphs and then histograms. And remember, the main differences between bar graphs and histograms are the fact that, like, histograms will be using quantitative data, right, on your x-axis, and bar graphs will allow for qualitative data, right? They'll allow you to do categories and stuff like that instead of, you know, instead of having everything be like on a constant scale and whatnot. So let's put quantitative, I want to say histograms, just so you guys know, and so you don't forget. Okay, so histograms and stuff. But yeah, bar graphs can definitely be, bar graphs you can also use for quantitative data as well, because a huge thing about what bar graphs do is they'll usually have like rates and percentages on their x-axis, right? And then when we, thinking back to histograms also, remember we had to have quantitative data on the x-axis, but remember the y-axis on those histograms have to be frequencies or relative frequencies. And what are frequencies? They're like the number of times that a certain thing is happening. It's like you're tallying them up. It's not like it's not a percentage or anything like that, right? So that's one of the main things about histograms that, you know, when you're comparing and contrasting with bar graphs. Also, remember how important it is that you draw your scales, or you scale your bar graphs appropriately. Because we saw a few examples of what can happen if you make them way bigger than they should be, okay? We can kind of skew the information and we can present it in a totally different light. You could make, you know, something that is a problem seem like it's not really a problem, okay? And remember I said a lot of politicians will do that, and even, I mean, marketers, researchers can also, you know, do that when they're trying to prove their point. Okay, so you do need to watch out for that. And I hope that after you've seen those examples, you can actually spot the BS and a lot of the other graphs that sometimes people will present. Okay, draw your graphs to scale. That's what, you know, make your graphs legit. Draw them to scale. Don't do anything weird. Don't try to, you know, manipulate the interpretation or anything like that. Okay, and then also remember we gave the shout out to Pareto charts, and Pareto charts are not really used in healthcare. Okay, now let's start looking at pie charts. So pie charts, usually pie charts are, you know, drawn as a circle, like a pie, and that's why they call them pie charts. But and the thing about pie charts is they're kind of really easy to read, because they're mutually exclusive. And what mutually exclusive means is that all of the individuals that you are surveying, that you're gathering information for, they can really only be part of one category. Okay, like for example, if you look at this one right here, okay, the question was, do you receive annual bloodborne pathogen training? The only answers that you can get are yes or no, okay, from your samples, okay? So, and then of course they fill out the chart accordingly. There's no, you know, yes and no, like I fall within both categories. It's either that you do or you don't. Okay, so a lot of these, it's very black and white. It's either or, okay, with these ones. All right. And these are actually, these are like really common in healthcare actually. Okay, so you'll see a lot of these. Okay, here's a little bit more about the features of a pie chart. On the last slide, I forgot to let you guys know that the last one was a qualitative chart. Okay, so that one was more because the options, the yes or no options are more categorical. They're not quantitative where you would be measuring something numerically, right? But you can actually use pie charts for quantitative or qualitative data. So the qualitative data example was on the previous slide. This one is going to be a quantitative, okay, quantitative data set, right? So this is just like a really quick example. Like this is fake. This isn't even real. This isn't you guys or any of my classes or anything like that. I just made a fake one. Like what if these were points on a 5-point quiz? Okay. And so you would have the different percentages of how students did on their quiz, right? Well, how many students, the percentages of students that did, that got a certain amount of points on their quiz. And then here's your legend that tell you exactly how, which color corresponds to how many points that group of students got on their quiz. So the main thing about pie charts is that everyone has to fit into just one category. You can't be part of anything else. Okay, you can't be part of both. You can't say yes and no. You can't like get 2 points and also 5 points. You can't be part of both groups, right? They're very exclusive, mutually exclusive. Okay, so all right, let's move on. Okay, so how do we even make a pie chart? Like, I mean, I know that we probably all in 2nd grade were learning about pie charts and we all got to make one. And when they allowed us to make our little pie charts about, what everyone's favorite TV show was or something like that in 2nd grade, a lot of us, or I don't know about you guys, but we did not draw this properly. Okay, we didn't do the math properly. We didn't do anything like that. What we did was we drew in our circle graph what we thought the proportion of that was, and then we would just fill it in and be like, there we go, that's our pie chart. But if we're in college and we're going to do this in the legit way, so we can't just do that kind of thing anymore. What we are going to do, I'm going to show you exactly like if you were going to draw this by hand, how you can draw it to scale. Okay, so if you're drawing it by hand, of course you have to go pick yourself up one of these things, right? These protractor thingies, whatever they're called. This is a very, very useful tool. Okay, so you're gonna go ahead and get yourself one of those, or you could just be doing all this in Excel. But let's learn how to draw this by hand. So you're gonna get your table first. All right, you're gonna look at you're gonna create your table with your raw data and all that, and we're gonna figure out exactly what the percentage of the pie chart it's going to be. What each class is going to be in your, what proportion they're gonna have on your chart, and then also this will help us figure out exactly what degree of the whole what proportion of the circle, how we're gonna be able to measure that, okay, in degrees and all that using the protractor. So this will help us be able to accurately draw the sections that correspond to each class, okay, or the frequency, in each class. So first of all, you're gonna have if you're doing a quantitative study, you're gonna put class here. Okay, and that's when you're gonna have your, it's gonna be more of like a quantitative variable or a constant or something like that going down here. You could even use temperatures, time, Here it's going to be points. But if you were doing a qualitative study, like in that the previous, like a couple slides ago, you would just put category here. Okay, you could just put category here, and then it would be like yes, no, and then you'll create your frequencies, your percentages, and then figure out the degrees for each proportion, and boom, create your chart. So anyway, we got our classes here. Next step. Now we have our frequency. So how many times did, each, in this case, we're using the whole 5-point quiz thing. So what we're looking at is how many students got 0 points, how many students got 1 to 2 points, how many students got 3 to 4 points, and how many students got a full 100% of 5 points total on their quiz. Okay, so you're gonna write your frequency here, how many students got each score, right? And then figure out your total, which in this case it is 37. 37 fake students for this fake quiz. All right, next, what you're gonna do is now we're gonna figure out the percentages or the proportion of the circle that each class or each frequency is gonna occupy. So what you're gonna do is you're going to take your frequency from this side, all right, and you're going to divide that by the total. Okay, so for the first class, 0 points, we got 2 divided by 37, which is going to be 0.05, and essentially this is 5%. You know, just if you didn't know, what you do is you move the decimal to the right two times, sorry. And then that is how you get your percent. So this is 5%. All right, so then in the 1.1 to 2 point class, we have 13 students divided by the total, which is 37. And then you're going to get 0.35, which means 35%. Okay, and so on and so forth. So you're going to do that same method all the way down. Okay. Boom, and then there you go. All right, so then we're gonna figure out exactly what degree or how we're gonna draw it. All right, so we do need the degree so that we can figure out the proportion using this protractor. Okay, and we'll be able to draw our little pie chart to scale. Okay, so what we got to do is we will take the percentage or the point, whatever answer we got here, it's going to be a decimal. Okay, we're going to do this in decimals, but you're going to take your 0.05, multiply it by 360 degrees, and then that will give us 19 degrees. So then you take your little protractor over here, and you're going to look for 19 degrees. So look, this would be 10 degrees. This would be 20 degrees, right? So 19 degrees is probably like here. Okay, so pretty much when you draw that one, it's going to be like that. Okay, and so that, you could fill that in and all that, make it look nice, and then that would be your 5%, right? So then you're going to go over here, figure out your next one. We have 0.35 times 360 degrees, and we get 126 degrees. So now we're going to try to figure out what that is on here. So what we can do is we can start from right here and then figure out exactly 120 degrees is using this whole scale. I'm just gonna go like this because this would be way easier since it's already numbered. You can literally pick up your little tool here and move it to draw the next one. And since we got to do 126, let's start from 0. Okay, and then you can go, where's 126? Like maybe it's like that. Okay, so like this level of a proportion is what your 35 is going to have, okay? So then you can like kind of outline it on your pie chart and fill that in, you know, like that. And you can kind of see these shapes that we're drawing here, that I'm kind of drawing in an ugly fashion. It is pretty much equal to what we see here. So it's the same, pretty much the same shape. It's a little bit larger scale, but pretty much the same thing. Now, like, you'll do the exact same thing. Like for the next step, go ahead and check. So for the third one, we got 0.41 times 360 degrees, and we got 140 degrees. All right, so we could start at 0 again because it's just so much easier to do that. And then go to 146, which is like here, I guess. And then like that would be the next one, okay? So that would be that proportion. And if you can tell, like it's the same shape as this one. So we're doing it, we're on the right track. All right, so then you can color that in your circle and, you know, make it look nicer than that. So you get the idea. I probably don't need to do the last one, but so that's how you would draw it. Okay, so another few notes on the pie chart deal. Okay, so like I can't stress this enough, they have to be mutually exclusive categories. Like, let me show you, like for example, okay, remember back in 2nd grade when you did this, right? And you went around and you asked all the kids in your class and you're just like, what's your favorite color? And everyone just would check their favorite color, and then you created that nice little pie chart, you know, by hand. That really probably was nowhere near upscale. But it worked out because you could read the pie chart, you know exactly which color everyone likes, which color people really don't like, and you know what is everyone's favorite, what's, you know, not everyone's favorite. But what if you created a survey where you were like, okay, everybody just check off all the colors that you like. Okay, so you would have people going through the list of colors and they'll be like, okay, I do like purple, I like me some magenta, I also like green, I like some blue, I like that blue, I like, you know, and they would just check off all the colors that they like. Well, you can't, when you have data like that, where you'll have like one, like each individual in your data set is going to, you know, they like all these different colors, okay? That's bar chart land. You can't do, or that's bar graph land. You can't create a pie chart out of that, okay? Pie charts are like black and white, okay? They're strict, they're exclusive. You can't jump from category to category. You can only have, like, every person that answers your question can only pick one thing. That's the rule there, okay? You can't allow your individuals who you're giving your survey to, you cannot allow them to have more than one choice, okay, if you're doing a pie chart. But if you are allowing them to go all out like that, you have to, that's bar graph land, okay? So that way you can, that's even like histogram land, where you're gonna have to like count the frequencies and all that. So depending on what you want to do with that data, you're gonna use a different type of a chart. Pie charts that will not work with this type of a chart, okay? Okay, so recap on pie charts. Pie charts are definitely common in healthcare, and remember, mutually exclusive categories only. You can definitely use this for qualitative studies and quantitative studies. So, you know, it's like on one hand you have a lot of options. You can use them for both sides, but at the same time, you just have to be careful about the questions and like what you want to include in your pie chart. Of course, you have to make sure that whatever you're asking is going to be mutually exclusive. Like your sample size, the individuals in your sample, they can only choose one answer. Okay, you can't, that's the only way this can work. Okay, but this can work for a lot, and you can do, they're so nice to read, they're very clean, they're great It's just that you can only use them specifically for, you know, certain certain types of questions. But okay. Now on all graphs, a recap on all graphs now. All right, so what I need to let you guys know from here on out so that you don't, you know, make any mistakes in the future, especially if you're doing, you know, research in the future. Make sure you always label everything. You need to have your title, okay? It needs to have a title no matter what. Otherwise, no one knows what you're talking about, okay? You need to label your axes, okay? You need to label your x-axis, whatever that is, time, dates, categories, whatever you got going on the x-axis, and you definitely need to label your y-axis as well. So is the y-axis, are these percentages? Is it some sort of rate? What kind of a reading did you get? Is it just a frequency? What type of chart? Like, you cannot just allow, don't ever just think that people know what you're doing, okay? Don't leave anything to assumption, because people are going to read your graphs wrong and they're going to get the wrong information. And if whatever you were doing wasn't for school, like if you're doing something very, you know, if you're creating professional graphs, if you're creating graphs because you need a grant for research, or if you need to convince a politician of something, or if you need to even if this is for marketing and you need to convince the rest of your team that all your customers like dogs and not cats or something like that, you have to be able to label everything and make your charts perfect. Your charts have to be readable. Okay, don't allow your team to go, I think he means this when he put that up there, so let's go ahead and create this marketing campaign about that and then have the whole thing wrong. Okay, so labeling everything is probably one of the most important things. And also sometimes you guys or me, like we kind of forget what we're doing, so it needs to be very obvious what you're doing in this graph. Like whatever they did here for this example, this is totally bad. All right, yes, we can tell that this is a date, but what are they even doing? Okay, and what type of readings are these? So anyway, graphs need to be clear, okay? Okay, so this is going to be just a recap of the different types of graphs that we have gone over to, you know, some level in this so far in the course. Okay, so first of all, let's look at the histograms, the relative frequency and then the frequency histograms. These are almost pretty much the same, so let's look at them together. Just to recap, whenever you are going to do a histogram, you're doing it for quantitative data. You're not doing this for any kind of qualitative data. So you're not looking at qualities or anything like that, no categorical stuff. This is strictly quantitative data. Quantitative data is where you're looking at quantities, you're looking at measurements and things like that, right? So, and you want to use histograms when you're trying to figure out the distribution. Okay, you want to see what the trends are, you know, what's going on there. Okay, it's good to look at trends. It's good to look and just see if you have a lot of people who are like completely on one side and then a lot of people completely on another side, you know, and things like that. So, and I know that if you need a little bit more on histograms, you can go look at the previous lesson where we went over that, and then it shows all the different types of distributions. Okay, so if you need a quick recap on that, you can go ahead and go back, look at that stuff. That is sort of important. Next, stem and leaf display. We didn't really go over this too much, but it's not that big of a deal, and it's not going to be that much different from a histogram. It's just a little bit easier to draw than a histogram, but it's pretty much, you're using it for the same thing, the same purpose. Okay, so you're going to use this specifically for quantitative data, and also the purpose of, you know, drawing this type of a chart, okay, this type of a graph is to see the distribution. Okay, So distribution, quite important. Next, let's look at the time series graph, or talk about time series graph. Okay, this is a fun one because this one is where this is like what they like to use to see what is going on over a period of time, like with epidemics or pandemics or just things like that. Okay, so we can see the changes over time with like COVID. So that's kind of interesting. Or with influenza or anything like that. Really just anything that you want to see a major change over time. Okay, if you're graphing a variable that changes over time and you're measuring it at regular intervals, time series graphs are really cool to see like how it moves throughout time. Because maybe it'll do something like this, and you're gonna be like, oh no, it's extreme now, or maybe you'll see a trend that goes like this, like it was really bad at one point and then it went down, and then you'll be like, wow, we solved our problem. So time series graphs are fun. I guess that's my opinion. Anyway, bar graphs. Yay, bar graphs. Okay, bar graphs are a little bit generic. Okay, I forgot to mention that histograms are a type of bar graph. Okay, don't forget that they are a type of bar graph, but they're more exclusive to quantitative data, and you just want to see your distribution when you do histograms. Bar graphs, a bit more generic. They're good for qualitative and quantitative data, and also for displaying frequency or percentages. Okay, so you can use this for both kinds of data, and it's a really good way to just look at what's going on. What is the percentage, what's the frequency, what's the problem here, how great is the problem. And also remember with bar graphs is that you want to make sure that you have an appropriate scale. You draw it on an appropriate scale. Because remember what we saw, if you make the scale too big, the data doesn't change. The data will just look extra small, and it'll look like it's not a big deal and completely throw you off. So, for those reasons, you got to be careful with what you're doing for your bar graph. Anyways, let's look at Pareto chart. The shout out to Pareto chart. Again, Pareto charts, you're not going to see them much in healthcare, but these are basically for documenting like frequencies of rare events or problems in descending or ascending order. Well, descending order actually, specifically descending order. So it's like terrible problem to smaller problem, It was something like this, and you'll see the trend doing that. So this likes to highlight what are the huge problems going on with that thing. The problem with this, and why we don't see this in healthcare very much, is because it doesn't provide enough information. Okay, in healthcare we need to be really specific about what's going on. So when we looked at that Pareto chart example, it was like it just left us with so many questions. And okay, maybe they're just talking about mechanics and whatnot, so maybe it's not a big deal, but like if you were talking about in healthcare, we need to know like what time frame, how many people are involved, things like that. So that's why Pareto charts typically not used in healthcare. Lastly, but not leastly, we have pie graphs, okay, or pie charts. Now these can be used for quantitative or qualitative data, and remember, they're mutually exclusive categories. So if you ask questions where you're asking for like a black and white or black or white type of an answer, like just be direct with me, tell me yes or no, or tell me what your favorite color is, or those type of questions are the ones that you use for your pie charts. Okay, you can't ask questions to your samples about you can't ask them any kind of question where they can have an answer that includes a variety of different variables or different categories or anything like that. You have to ask questions where the answers are going to be placed in mutually exclusive categories, and that is the only way you can get a good pie graph. Okay.